Okay, part 2A of your database, introduction to database. We're going to talk about data redundancy and data dependency, right? So let's see what this is about. Okay, what exactly is data redundancy? Data redundancy refers to the same data being stored more than once. So for example, in this table here, right, we have civics class and civics tutor. Because the students are in the same class, right? So these two columns of data are redundant, right? So you may think it does not take up much space. Why can't you just have this extra columns here? Because it's good to have, kind of, right? Okay, but let's see what are the problems associated with data redundancy. Okay, when you have redundant data, right, you're gonna have some issues when you insert or when you update or when you delete data from your database. So for example, let's look at this class here. If I want to insert data, right, I cannot insert a new student record if I don't know his civics class and civics tutor yet. Right, so because let's say a new student coming in, he needs to take a subject selection test. Then before that, we want to put his name in. We just need to give him his metric number, name, and gender, right? But we don't know which class he's going to yet. Because we don't know the class, we don't know which tutor will be his civics tutor, right? So that's going to be some issue. Okay, but what if the case, let's say your civics tutor is transferred out of school or resigns from service, then you need to change a new tutor, right? Then you have to update every single record. Okay, so for all 10 records, you have to be updated one by one, right? So you have to do it. Okay, and then if you want to delete if let's say maybe after a few years you say this class has already graduated, you don't need the record, you want to delete the entire table, right? But when you do that, right, you're also removing the information about the class and also the civics tutor, right? So this is something that I want to avoid as well. All right. So let's go on. So that means we need to get rid of data, make sure there's no redundant data. Right. Next concept we're going to look at is called data dependency. Okay, we need to learn how to normalize data. Right. So because if we want to reduce redundancy here, we need to normalize it. So we talk about normalization in the next section. But before we do that, we talk about data dependencies. So we could consider about two types of dependencies here, functional and transitive dependencies. Okay, let's see what we are talking about. Okay, what exactly is functional dependency? Okay, so let's read the definition first. Attribute Y is functionally dependent on attribute X, which is usually the primary key, if for every valid instance of X, the value X uniquely determines the value of Y. So Y is functionally dependent on X. So for example, here you have your same table, metric number, name, gender, civics class, and civics tutor, right? Alright, so metric number is a unique number assigned to every student in college. Alright, so metric number uniquely identifies the name. So once we know the metric number, we know the name of the student as well. Alright, then from there we can say that the name is functionally dependent on the metric number. Of course, you might be able to see some other functional dependency. So gender is linked to metric number as well. All right. Okay. So this is functional dependency. All right. So then let's talk about the next one, transitive dependency. Okay. So let's do long definition again. Functional dependency is said to be transitive. It is indirectly formed by two functional dependencies. Okay. So let's look at this example. Z is transitively dependent on X if Y is functionally dependent on X, but X is not functionally dependent on Y, and Z is functionally dependent on Y. So Z is transitively dependent on X, provided this holds true lah. Okay, so you can read this, but I think let's look at an example here. Okay, so let's look at civics class. All right. So civics class, right, is functionally dependent on the matrix number. You know the matrix number, you know the name, you know the gender, you know the civics class of that student, right? But it's not the other way around. Your matrix number is not functionally dependent on your civics class. So you know the civics class, you might not know the matrix number. So in this case, this is a one class example that's not so good. But let's have a second class, let's say 18A02, right? Knowing the class is 18A02 does not tell me which metric number it is. In fact, even if there's only one class, right, if I give you one metric number, one civics class, right, you will not be able to pick out the metric number of the student, which I'm referring to lah. So this is a one-way functional dependency. So civics class functionally dependent on metric number, but not the other way around. Okay, next, civics tutor is functionally dependent on the civics class. Alright, so if you know the civics class, you will know the civics tutor. That's what I say. So right now we have a case where civics class is functionally dependent on matrix number, civics tutor is functionally dependent on civics class. So that means civics class is transitively dependent on matrix number, because once you know the matrix number, you know the class. Once you know the class, you know the civics tutor. Okay, so this is transitive dependency. Okay, so this is end of part 2a. You can proceed to watch the next video on part 2b, normalization.